to help with some questions that people have asked about taking some derivatives. So we have this thing called the product rule that tells us that the derivative of the first variable times the second. If we want to take the derivative of that product, we have to do the first times the derivative of the second. So I'm going to represent that with d second plus the second variable, whatever that is, times the derivative of the first. And we'll show you what that means in an example in a moment. And then we also have this thing called the quotient rule. So if I want to take the derivative of a quotient, I can take this upper part, the numerator, here I'm calling it high, and I have this lower part, the denominator, I call that ho. If I want to take the derivative of that, I need to do ho, the denominator, times the derivative of the top, so d high, minus high d ho, high, times the derivative of the bottom, all over ho-ho. So these are the ways that I remember these general rules. The product rule is the derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. And the quotient rule, the derivative of high over ho, is ho d high minus high d ho over ho-ho. And I've just memorized those since high school. Those are stuck in my head. So let's do an example. Let's see how this kind of works with a problem. So let's say I'm given a velocity, and let's say that velocity is v equals v naught, some initial velocity divided by 1 plus, we'll say a capital A, some constant, times t squared. Now if I want to find the acceleration of this, I need to take the derivative, because the definition of acceleration is dv over dt. So I need to take the derivative with respect to time. In order to do that, the time is my only variable in here. Everything else I can imagine is just a number, is just some kind of constant. So the time is the only thing that I really have to differentiate. So I'm going to take this derivative, and since I have a quotient here, I'm going to use the quotient rule. So the quotient rule, I'm going to take the derivative of this whole thing. I'm going to have ho d high minus high d ho over ho ho. So to take this derivative, I take the ho, which is the bottom part, the denominator, which would be 1 plus a times t squared, times the derivative of the top part, ho d high, derivative of v naught. Now there's no t's here. Because there's no t's, there's no actual variables. So as far as this derivative is concerned, this derivative with respect to time, v naught is just a constant. Derivative of a constant is 0. So it's going to be all of this 1 plus at squared, the ho, times 0. Because that's the derivative of this numerator with respect to t. And then I need to subtract off high times the derivative of the bottom. High, the upper variable, is going to be v naught times the derivative of the bottom. Now the derivative of the bottom, I can just take that derivative. I look at the 1 first. Derivative of 1 is 0, so I don't have to worry about that. And then I need to take the derivative of the second part, this a times t squared. Here I need to use the power rule. You can go to the lecture, you can go all over Khan Academy, you can find lots of videos that tell you how to do that. I take this derivative, I have 2 times capital A times t. That's the derivative of the denominator. So I've got ho d high minus high d ho, and now I need to divide all of this by ho ho, by 1 plus at squared times 1 plus at squared. And this would be my answer for my acceleration. I could leave this equation. We could simplify this as well. We could get acceleration because I've got this 1 times a plus at squared times 0. That's going to cancel out because I'm multiplying by 0. So I have a negative of 2 times v naught times a times t. Here I just move the 2 out front. No big deal. That's just very basic algebra. And I divide by 1 plus a times t squared, and I would square that because I'm multiplying them together. Looks like I lost a little squared up there, so we'll put that in. Okay, so that's how I would solve this using the quotient rule. I could also do this problem using the product rule. And I mentioned this in a discussion board question that somebody asked in chapter 1. So how would I do that? Well, I would rewrite my original equation. My v equals v naught over 1 plus a times t squared. I don't like working with quotients. I don't like division. So I can rewrite this as v equals v naught times 1 plus a times t squared raised to the negative 1 power. This is the exact same thing. This is still a quotient, but now I can use the product rule to take this derivative. So the acceleration is still dv over dt, and I can take the product here. So if I do the product rule, I do the first variable times the derivative of the second. So this is my first variable. All of this stuff is going to represent my second. So I need to do the first times the derivative of the second. First variable is v naught times the derivative of the second. To take the derivative of the second, I need to use the power rule. Now the power rule has to be applied to this stuff that's in parentheses. So the power rule means I take whatever this variable is, or whatever my exponent is, I bring it down front. So I have a negative 1 that comes out front. Then I take whatever's in the parentheses, all of this stuff, and it tags along. It just gets written straight away. So I have negative 1 times 1 plus a times t squared. And then I take the exponent, whatever the number is up here, and I subtract 1 from it. So instead of negative 1, I would have negative 2. And then the last part that's most commonly forgotten, is I need to take the derivative of whatever is inside of these parentheses. Okay, so this is the power rule, and something called the chain rule as well. So to take that derivative, I take the derivative of all that stuff that's in the inside of that parentheses. So the derivative of 1 with respect to time is 0, because there's no t's in there. So I take the derivative of the second part with respect to t. With respect to t, I use the power rule there. I get 2 times a times t. So that leaves me with my acceleration equation is going to be negative v naught times 2 times a times t, all divided by 1 plus a times t squared, all of that raised to the second power. And we see that that matches with what I got from the quotient rule. They're the same thing. You can use either approach that you want. Doesn't really matter. That's the product rule and the quotient rule, and an example of both of those.